Let's see. That's not the correct microphone. I want the regular, the unadvanced properties. Here. Nope. There we go. Yeah, cool. I always know it's the condenser mic that's been turned on because if I let it go down, it has a much, much lower it has a much lower baseline than the other microphones, which means that it has less noise, which is why it's less annoying to listen to. How was my week? My week was pretty busy. Like, I don't know, guys. I don't know if where you guys are. There's a lot of snow. There's been a lot of snow over the last couple of weeks. So I don't. You know, it was a pretty physically intense week, shall we say? But that's good. You know, being around the house all the time, you need the physical activity. You know. So, Ella brings up a point that has also been on my mind this morning. Can we try to cover recursion this week? We see it on assignment 4. Yes, so I would like to, first of all, offer my most sincere and humble apologies to the class for the fact that we have gotten behind on the lecture material to the extent that we have gotten. It is normally I'm off by, you know, a few lectures, 1 or 2 lectures behind. Busy and unproductive. Oh, that's the worst combination. So the like there are reasons for it, right? You know, like in a regular sort of there are semesters when the class is mixed up with the comp sci people and semesters when it's not, right? And when there are comp sci people, there are like lots of people sort of on hand that know a sufficient amount of stuff about programming that it's, you know, it helps the class move along. Essentially, I'm going to try to make the argument that the reason we have found ourselves to be so behind on the lecture material is because I have been taking the time to try to like go over in sufficient detail the parts of the course that will be difficult for people who don't know programming. You know, theoretically, this is an introductory programming course, and theoretically, you shouldn't have to know any programming to be able to succeed in this course. So, you know, we've been going over the basic constructs in more detail than I did last semester, for instance. If you compare the lectures that we've been doing this semester to the ones last semester that are on my channel, you'll notice that. So, the problem, of course, is that we have come to the point where a remedy is required, because the problem that we're going to hit pretty soon is that the assignment material is going to it's currently outpacing the lecture material by a goodly bit. So, you know, as your esteemed colleague points out, there's stuff on assignment 4 that we're not likely, like we've still got probably a lecture or 2 left in topic 4 before we even get to topic 5. Topic 5 being the one where that material is covered. So the probability that we're going to be hitting the functions and recursion material prior to you requiring, you know, that knowledge for your assignment, let's just say we would not be able to do justice to the remaining elements of topic 4. So, can the assignment be easier and more related to the course material? Yeah, so it is related to the course material. I'll leave that aside. So this is what I think a remedy to this situation might be. Here's my proposal. Let's take these weekly assignments and push them back by a week. All of them, right? Every single one of them. So A4 will be due when A5 was going to be due, A5 will be due when A6 was going to be due, etc., 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 etc. And we'll take the last assignment, which is kind of... I've always viewed Assignment 10 as being like a summative exercise, because it sort of uses everything in the course. Let's make that an extra credit assignment that's optional. So, hopefully this is like, I don't know. What do you guys think? Do you think that's a good proposal? Am I shattering dreams with that proposal? I don't think so. Usually students are pretty... usually you don't usually make students angry by giving assignment extensions. But what do you guys think of that as being a solution to our current situation? Ella likes it. Haley likes it. Lacey likes it. Okay. 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 All right. So, yeah. Okay. All right. We'll proceed on that basis then. Okay. Okay. Yep. That's... Oh, okay, yeah, those are some good questions. So, how about I'll give you this, because you guys raised some interesting and important questions with respect to how Assignment 10 will be made a like bonus/optional thing. Let me get back to you on that. I'll have a word with the TAs, see what they think about it. I'll do some consultation, and hopefully by tomorrow I'll have a more firm idea of the particular manner in which we will make Assignment 10 a extra credit assignment. To be completely honest with you, I've never done an extra credit assignment. It's always been bonus marks on existing assignments. So we're gonna have to take a look at the Avenue system and see what would be a good way of going about reconfiguring things so that that's an extra credit assignment rather than the current system, which is bonus marks on assignments. We'll have to see. Okay, so we'll see, but yeah, I'll get back to you guys on that issue of the particular manner in which Assignment 10 will become, how that will integrate into the course. I'll update the course syllabus and all that in order to reflect the changes. Does this mean that we would have 2 weeks to complete each assignment, or they would continue to be released 1 week after the due? That would mean... No, it wouldn't be 2 weeks per assignment, because if it were 2 weeks per assignment, the last assignment due date would be sometime in June. So, no, unfortunately, given the number of assignments, we can't make each one a 2-week assignment, but we can offset them so that hypothetically the lecture material is covered in advance of you working on the assignment. Yeah. Yeah. Yeah, extra week for assignment 4. The rest of them will still be due every week. Yes, good summary. So, yeah, anyway, on the subject of not getting any further behind on the lecture material than we already are, let's actually talk about our lecture material for today. Hey? Cool. All right. So everybody, when you're writing up your course evaluations, don't say that the professor wasn't responsive to the changing situations and needs of the class, because that's I try to make the course feasible, and that sometimes requires adjustments like that, such as this one. Please note that I did put in the syllabus these deadlines and due dates are subject to change with changing circumstances. That's sort of that's what we're doing right now. So yeah, anyway, normally people don't get, people are usually okay with extensions on things. So, anyway, so let's talk about what we were talking about before the break. So we were talking about sets. I believe we sort of got into sets, but we didn't quite get all the way through sets. So yeah, that's, what will the weighting of each assignment be? Will the weighting of each assignment be more than? Yeah, so, the assignment grade, like the assignment portion of your grade will stay at 40%. Like not considering what I'm doing with assignment 10 right now, but yeah, like each assignment will be worth, take 40, divide it by 9, that's how much each one will be worth. Okay, so, let's talk about sets. So, sets, okay. Let's get back into material. We were talking about data structures, right? We were talking about lists, tuples, lists, strings, sets, and dictionaries. These are the 5 data structures that you have to worry about in Python. Sets are kind of an ancillary topic. They're not really used that much, but it's still important to know what they are and go over them, because they're a good introduction to how dictionaries work, and dictionaries are actually reasonably important. So, so a set. When we're talking about sets in Python, we're talking about sets in the same in the sort of conceptual framework that we were talking about, that we talk about sets in a more formal mathematical setting. So, sets as in set theory. Sets as in Frankel-Zaramello set theory, right? Mathematicians will know what I'm talking about. So, a set. A set has certain characteristics. Number 1, it's an unordered collection of objects. Because it's an unordered collection of objects, there's no way of getting at the things that are inside of a set using indexing. So, if we have a set, sets are syntactically, you use curly braces. I'm just going to add some random numbers here. First of all, the elements in the set are in no particular order. So if I were to say I want the third element of this set, it says set object does not support indexing. So you cannot use indexing to get the stuff in a set out of a set again. There are some ways, which we'll see in a bit. The other thing about a set is that all of the elements in a set are unique. So, and that's actually the most interesting and important property of sets in Python. So, you notice that when I constructed this set, I used a random assortment of numbers. However, only those elements of the original request that were unique were kept. So you can see the second instance of the second and third instances of the number 2 were dropped. There is only 1 2 in the set. If you have a string like hello world and you convert it to a set, only those elements that are unique to the set are kept. And this is also a very interesting and important thing. Notice that okay. If you looked only at this numerical example, you might get the impression that the sets are being ordered according to the ordering of the elements of the set. That's how it's being displayed here, right? However, if you sorted the elements in a string, you would sort them according to what the ASCII values of the characters are. You remember the ASCII chart that we covered earlier, right? So notice that the elements in the set are being displayed in what is essentially a random order. It's like a quasi-random order. I want to reinforce that the elements in a set are not ordered. They are not ordered according to the order in which they are added to the set. They are not ordered according to their value. Any ordering that appears to exist among these elements is purely coincidental and cannot be relied upon. It's, there's a distinction between something being arbitrary and something being deterministic. It's deterministic but arbitrary. So what that means is if you perform the same thing multiple times, it'll come out with the same result. But if you you can't rely on whatever algorithm it uses to determine that ordering because it's arbitrary. The logic that exists in it is at a level that's inaccessible to your mind, is another way to put it. So yeah, you don't have to worry about that, though. All you have to think is, I cannot rely on the order in which elements exist in a set. Cannot be done. So, we have a few... Let me just check, see if people have a... For the assignments, one of them still gets dropped, so technically it's 40 divided by 8. Yes! Yeah, we're still dropping the lowest assignment, so... will a second test be shifted forward as well? No, we're not going to affect the... We're not going to change the days on we're not going to change when the tests fall, but we will change what the coverage of those tests are, if that makes sense. So the tests will not... Obviously, the tests are going to cover, the stuff that we've covered in class up to the point of the test in a reasonable fashion. We won't test you on stuff that's being taught after the test. That would be dumb, but we're not going to move the test dates. So the tests are going to get a little easier, but they'll be on the same day. Yeah. Cool. All right. So, with sets, we have set operations. I believe I covered these last time, so I'll only go over them briefly. If you remember from set theory, you have a couple of set operations. You have union, intersection, difference, and cardinality. The easiest way to display this is set operations, images, yeah. This is the easiest way. So, you have, so this is intersection, right? If you have a set A and a set B, the intersection is those elements that are in both A and B. Union is all of the things that are either in set A or in set B. So notice that there's actually an underlying similarity between set operations and Boolean operations. Give me 2 seconds. Sorry, give me 1 second. Sorry, I just had a refrigerator running moment. I had to check to make sure I'd taken my keys out of my car because I was moving my car to shovel snow this morning. Anyway, sorry. So, union is like an OR operation, and intersection is like an AND operation. So, You also have difference. Difference isn't here, but it's all of the elements in A that are not in B. If it's A minus B, you use subtraction to indicate that. And cardinality is just, it's like the length operator, but applied to a set. In fact, when you take cardinality, you are actually using len, our now well-familiar len function, which just tells us the size of a data structure. Apply it to any data structure, and it will tell you what the size is. So the actual operator for union is bar. If you program in any other language other than Python, bar is what is, like, 2 bars are Boolean Boolean or. 2 ampersands are Boolean and. So that's where these operator symbols are derived from. Actually, in most situations, these are the same operators that you would use for bitwise operations. We won't really get into bitwise, but that's just operations over bits. Anyway, so yes, we also have a test for membership over sets in the same way that we do for lists. Just use the in operator. In general, most of the stuff that works on any particular operation will work on a set, except if it involves, like, indexing, right? Because you can't index over a set, because it's arbitrary. So we also have some operations to add and remove elements from a set. So if you wish to take a set and add an element to it, you do add. There you go. And it gets put in there. If you wish to remove an element from a set, you discard from the set. That removes it. And pop is kind of an interesting one. Because what pop does is it removes from the set and returns the thing it removes, but it removes something random. However, it pops things in the it pops things in the order that it displays in the terminal. So this is, again, not ordered, even though it looks like it's ordered. So let me see if there are any questions. No questions. Okay. All right. So one of the interesting things you can do with sets is you can use it to access only those unique elements of the set. Now, or of another data structure. So, like, again, it's actually exactly the thing I did here. By converting it to a set, we have extracted out a sort of the set of elements in that data structure that are unique. So if you can imagine this being a useful operation if you had a like a list or something. You can do this equally well with a list, right? Or, you know, right? If you convert it to a set, it takes only those unique elements. In this particular example, rather than using the set conversion the set type as a conversion operation, we are creating an empty set for every element in the thing that's passed in. We add that to the set using the union operator, and then we return the length of it. So that's just counting the number of unique elements in it. Again, it's you can essentially do that as a one-liner. But, you know, you can also use add. I'm going to skip this slide because it's another one of those rapid-fire quiz slides. So, just to review things so far, we have tuples, right? Tuples use round braces. Duplicates are allowed in tuples. The order in tuples matters. And tuples are an immutable data structure. Strings are essentially tuples by another name. Strings share all of their properties with tuples. However, they're, you use quotation marks, and, you think of them differently, even though they're essentially the same thing. Lists use square braces. Duplicates are allowed in lists. The order of the elements in a list matters, and lists are mutable, as we saw. And we have sets, which have curly braces. Sets do not allow duplicates. No ordering is possible over a set, and sets are mutable. So all of those things that we were talking about with respect to aliasing, that all applies to sets as well, although we won't go into any detail. We won't redo those examples for sets. So yeah, any questions about sets before we move to dictionaries? Does the set have to be named set, or can it be named anything? Yeah, no, you can name it, like, cheeseburger. Yeah, you can name it whatever you want. Just like any other data structure, you can apply any name that you want to it. In this example, I'm sort of using it implicitly without giving it a name, which means that it's not actually, like, there's no way to access this after this line of code is executed, but I didn't need it stored to a variable, so I didn't store it to a variable. But yeah, the regular rules for assignment apply. What if you add an element that already exists in the set? Will it repeat it? No, it will not. So in the example of cheeseburger, it already contains the element 2. So if I add 2, it doesn't add a second 2. Good question. Cool. So let's move right along. Let's talk about dictionaries. So the correct way to think about a dictionary is as a mapping between two things. So this sort of gets into some more sort of abstract mathematical territory, but do y'all know what a relation is with respect to mathematics? Perhaps you do, perhaps you don't. Do you guys know what a relation is? So relations and mappings are essentially the same thing, all right? So it's a reason, like functions in the regular, in like the mathematical sense, are also mappings. But the idea of a relation is a little bit more general. So if you have a set, right? A set A and a set B, a relation is some way of getting to the elements of set B from the elements of set A, right? So in this particular example here, if we have the elements in the set, in the domain set, which is the base set, the first set, -9, -5, 1, and 7, and then we have elements in the set B, which is the range, 1, 4, 5, and 8, these lines indicate means of getting from one element to the other, right? That's the idea of a mapping. Now dictionaries in Python are a very particular and specific type of mapping. They are a mapping where every element in the first set maps to one element of the second. Although, they are mutable data structures. So in theory, you can have some, pointers in there junking up that nice, pretty relation. But in general, the way that you'll be using dictionaries is as a mapping from one set of things to another set of things, where every element in one maps to one element in the other. So, for example, if we have days in month, we have January, February, March, and April. January maps to 31. February maps to 28, March maps to 31, April maps to 30. So in practical terms, what a dictionary is it's like a list, but the indexes can be of arbitrary type. So if we have a dictionary, dictionaries are denoted by curly braces. A is mapped to 1, B is mapped to 2, and C is mapped to 3. D at A is 1. D at B is 2. D at C, thank you, is 3. D at D is a key error. So hopefully this makes sense to you guys. Yeah, okay, cool. So dictionaries are actually pretty useful. I believe there were a few questions relating to dictionaries on the last assignment. So you guys remember the Dictionary of Dictionaries question, perhaps. In that question, we were orienting words to other words, right? So we were mapping between, a language and a word in that language, right? Or we were actually mapping between languages and other dictionaries, because dictionaries can be elements of sets that dictionaries point to. You can nest these things. So yeah, they're, in practical terms, if you want to leave all of the math stuff aside, it's a list, but you can use anything for the index, not just numbers. You can use numbers for it as well, though. So when you use numbers as the keys for a dictionary, these are called the keys, and these are called the values. So when you use numbers for keys, you're not one of the interesting things is that you're not bound by the ordering that's implicit over the indexes of a list. So the numbers can be any number, right? You don't have to start at 0 and go up. So you don't, if you wanted to do this, something like this, in a list, you would have to declare memory space up to the index 95, and the vast majority of that list would be empty, right? It wouldn't have any values in it, because you only wanted these 3 out of nearly 100. However, if you use a dictionary, you can give values to only those indexes that you're actually going to use, which is extremely useful. Cool. So, practical terms. Okay. I already said this, but the index is called the key, the value is called the value. So, in this particular days in the month example, January, February, March, and April, those are keys. And the numbers, which are the number of days in each of those months, those are the values. So, key, value, key, value, key, value, key, value. That's important nomenclature. Please get that into your brain. Oh my gosh, I hate it when I hit end! Ugh! Crap on a cracker. Alright, there we go. So here are some, here's your basic syntax for dictionaries. If you want an empty dictionary, which you may want, in some cases, want an empty dictionary, that is 2 curly braces with nothing between them. It should indicate to you how often dictionaries are used in comparison to sets, that a set that's empty is written like that, but a dictionary that's empty is written like that. Dictionaries are the primary, they're higher in the hierarchy of things people actually use than sets are by a long shot. The thing that differentiates a dictionary from a set, you'll notice they use the same braces, right? We use the same type of braces to declare sets as dictionaries. A dictionary is a dictionary because it has these colons in it. It has paired values with colons. A set has individual single values. That's what makes it a set. Pairs of values is what makes a dictionary a dictionary. You can look up a key E in the dictionary using square braces in the same way that you look up something up in a list. Slicing doesn't work, though, because dictionaries do not, although you can access the elements in them, those elements are not subject to ordering. In the same way that a set is not subject to ordering, a dictionary is also not subject to ordering. They're more useful, though, because you can actually get stuff out of them by accessing things through the index. So here's an interesting little caveat. When you use the in operator over a dictionary, you're not searching the values, you're searching the keys. So for D2, if I want to say 3 in D2, it says false. If I say 67 in D2, it says true. So when you use the in operator over dictionaries, it's searching the keys, not the values. That being said, you can search the values easily if you want to. So if you use the keys method, that gives you a data structure that contains only the keys, and if you use the values method, that gives you a data structure which is searchable, which only contains the values. So if you want to see if 3 is in the values of the dictionary, you do d2.values, and then that is true. Okay? So that's the thing about a dictionary, is if you mean to be searching the values, you have to specify it. Again, computers do not read minds. People also don't read minds. It's unreasonable to expect anything or anybody to know what's going on inside of your cortical cortex. Anyway, if you wish to delete something from a dictionary, you can use the del keyword. It deletes. So if we wanted to delete d at 67, or d2 at 67, d2, that element is removed. It's gone forever. Once again, if you wish to know how many elements there are in your dictionary, you use length. Notice that each pair counts as an element. That's an important distinction. This is another way of saying how many keys are there in the dictionary. So a key and a value do not count separately towards the total length. A key-value pair is the basic atomic unit of the dictionary, and that is what length is counting. And I already showed you how to use keys and values. Let me see if there are any questions. So dictionary is more like a function relation where you can do f of x as x is a key to get a value. Yes! Yes, Helen, that's like precisely what a dictionary is. Yes. It's like a discrete it's like a function in the the set theory sense, not in like the calculus sense. Although functions in the calculus sense are functions in the set sense if you consider the sets over which a calculus function operates to be the set of real numbers. Like if you consider a logarithm or something to be a function that takes a real number and outputs a real number, the real numbers are sets in set theory, so a function like the logarithm function in calculus is a set according to set theory as long as you define your domain properly. Yes. Can Boolean operators also be used like if value of D key to check the specific dictionary key? Yeah, absolutely. So if you wanted, for example, if 45 in D2 or 76 in D2, that's false. But if you wanted 97, which we know to be in there. That, what? Really? No, it's 95, sorry. There, yeah. So, yeah, you can chain, these are like Boolean expressions in the proper sense of it. Like, you should think of these as being usable in the same way that you would use, like, an equality function or something, right? Or a, inequality relation. So any of these things. Yeah, like anything that returns a Boolean actually can be used in that context. So even if you have, if you have a function, if you have a function that you yourself have written that returns a Boolean value, you can use it inside of a conditional in the same way that you would use an equality or anything of that nature. So, yeah! Good questions, guys. Good questions. I love it when people ask good questions. It means people are paying attention. So, you can, because dictionaries are mutable, dictionaries, you can use assignment operations over dictionaries. So, let's take our D dictionary. Let's say we wanted to increase the value of D at A. So, D at A is equal to 9. Assignment works. In the same way that assignment works on a list, it works on a dictionary. You can even use something like plus equals. That works. Totally works. And here's another interesting one. If you wish to add an element to a dictionary, which is probably a thing that you want to do, especially if you start with an empty dictionary and you want to build up a dictionary over the course of a loop executing, which is something that you'll probably see at some point. All you have to do is assign to a value that's not yet in the dictionary. And that adds it to the dictionary. There you go. And that's interesting because that's not a thing that works on lists, right? If you have a list that's like 1, 2, 3, 4, and you want to add something to the end of it, that doesn't work. This will give you an index out of range error. However, you can actually assign to things that are outside of the existing domain of a dictionary. Python automatically interprets that as an I want to add this to the dictionary operation. So that's kind of convenient. With a list, the equivalent operation, the way that you would do that is L is equal to L concatenate 5. And then that's how that works. So with lists, you have to think in terms of concatenation. With dictionaries, you think in terms of assigning values that haven't been assigned to yet. Cool. Can key values be changed? You can take the value that has been mapped to a key, assign a different key to it, and then delete the old key. But no, the values themselves, they're not to, like, you can't really mess with them. You can reassign values to new keys and delete old ones, but you can't really change the key itself. No. So the answer is no. It's like with many things in programming, it's like you can if you want to, using roundabout methods, but like there's no direct access to that type of functionality. Cool. All right. So, here's a quick little example. Use dictionaries to construct a histogram. So, a histogram, basically, it just determines the frequency of items in a collection, right? So, let's do this. Define histogram takes something S. We shall define an empty dictionary D for character in string. This is, like, clearly it thinks it's operating on strings here, but it doesn't necessarily have to be. If C not in D, D at C is equal to 1, else d at c is equal to d at c plus 1. So the reason for this branch, right, is although you can create a new dictionary element just by assignment, you can't use one that has not been created, right? So there's, like, again, putting stuff on this side of the equals sign, that might be a creation operation. At any rate, you're putting stuff into memory. You can't just use this statement because this value would not be defined unless you had put it in the dictionary. And since we're starting off with a blank dictionary, the dictionary has no elements on creation. So we have to put this in order to distinguish between cases where there is the key in the dictionary and cases where there is not. You can't access something before it's been assigned to. Same rule as with variables, really. Yes, and once we're finished all that, we wish to return D. Yes, cool. So, if we wish to print the histogram of all your base are belong to us, for example, you'll notice that there are 3 E's, 1 G, 3 O's, 6 blank spaces, etc., etc. Right? Cool. So that's cool. I'll see if there are any questions about that. I am not going to talk about A3 on stream. I'm going to continue this. We're going to get dictionaries done today. So, an important element of how to use dictionaries is how they interact with for loops. So, in the same way that the in operator deals with the keys and not the values, when you for loop over a dictionary, you're for looping over the keys and not the values. So for key in D, print key. It's not the key because I said it was. It's the key because it is. I just named it the way it is. So yeah, see, for key, like for Q in D, print Q, same thing, right? So these are the keys. If you want to for loop over the values, again, you have to get the values, and then you can for loop over them. Make sense? Hopefully that makes sense. So yeah, for loops. So here's one of the key differences between lists and dictionaries is lists normally you have a choice between whether to use a while loop or a for loop because a list indexes can be accessed reasonably easily numerically by, having a indexing variable and incrementing that each loop iteration, right? Because dictionary elements are not, there's no logical order in which they occur, you can't just get to the keys by math, unless you've specifically set it up that way. And if you have, why wouldn't you just use a list? For loops are really the preferred way of accessing the things that are inside dictionaries. I would actually not even recommend trying to use a while loop over a dictionary. Always use for loops, because they're just, they'll just give you the things you want without all of the fuss. There's no advantage to using a while loop over a dictionary, asterisk in most circumstances. So yeah. And this slide doesn't matter. It's just which type would you use for each of these situations. I will leave that as an exercise to the reader. Yes, good. Okay, that is time. Thank you very much for your time and attention. I'll stick around to answer your questions a little bit. And as long as those questions aren't, why can't I see my assignment 3 grade? Because I don't know. The marks came out while I was on stream. I have no idea. And besides, I usually forward those questions to Anna anyway. Cool. Anywho, yeah. Yep. When are office hours? Oh, that's a good question. Office hours are actually distributed throughout the week. There are office hours for someone on the team every day of the week. Anna's on Friday, Mark's on Wednesday, Swale's on Tuesday, Basil's on Thursday, and the other Mark is on Monday today. So other Mark is having his office hours at 11 today, so in an hour or so. My office hours are on Friday after, or not Friday, Thursday. They're on Thursday immediately following class. So, yeah. There you go. Good question. Send me an email about your situation there. Is there any way to loop over the keys and have the return value be the value in the dictionary? Yes, that's a good question. Good question. So, very easily. So, this is for looping over the keys. This is returning the values. You just access the values using the, regular dictionary notation. Will you get emailed your feedback again? Yeah, now that the email feedback mechanism has been established, we will be using it. We won't just use it once and then forget that it exists. Don't worry, we'll be emailing feedback. If you haven't received the feedback yet, I would encourage you to, you should always wait to see the feedback if the feedback is coming before, going to the TA and saying, I don't know why I got a bad grade. It's like, well, I don't have your thing, so I can't tell you because I don't know. Anyway. Cool. All right. If that method is used with a nested dictionary, what is returned? If you use a single index on a nested dictionary, you will get a dictionary back, right? So, if we set up a very simple nested dictionary, just quickly. Right? So, for Q in D, print D at Q, you'll get the dictionaries back. Make sense? In order to get the stuff inside of it, you'd have to use a loop within the loop, right? So, for Q in D, for R in D at Q, print R, D at Q at R. Right? Make sense? Cool. I need to shovel the rest of the snow before it all turns to slush. So, yeah, gross. Anyway, take her easy, folks. Be glad you don't live in Canada right now if you don't live in Canada. Take her easy.